Hello students, so let's study about the shear form of the cyclohexane. Okay, here you can see some of the diagram. Here it is shown that cyclohexane exists in shear form, but the question arises, why actually it exists in shear form? Like, why can't it exist in a cyclic form like other compounds? See, it can be exist as cyclohexane, but it doesn't exist like this. Reason: see, in cyclohexane, all carbon are sp3 hybridized and the bond angle should be 109.28 degree. But in cyclohexane, see this bond angle. If you calculate this bond angle, it will come out to be 120 degree. It should be 109.28, but it is 120 degree. So there is a huge difference in this bond angle, and due to this there is the angle strain in this ring form. What is the angle strain? Okay, so this is the one of the reason that it don't exist in this way. Another reason, if it would exist in this form and we draw its Newman projection, see, I have drawn one Newman projection here in this diagram. This Newman projection is in staggered form, okay? But if you draw the Newman projection for this cyclohexane in planar way, it will come out to be eclipsed form, eclipsed form, which is again very unstable form. Eclipsed form means there is a torsional strain, means if it would exist as a planar, then there will be, first thing, angle strain, second thing, there will be torsional strain. Okay, so these two strain avoid the cyclohexane to exist as a cyclic form like this. So now what will happen? We need to put all bond angle in this way, 109.28. all bond angle must be there. When we try to connect carbon with one another, maintaining this bond angle, then what will happen? In that case, you will get the geometry like this only, the shear form of the cyclohexane. This type of shape you will get, shear form of the cyclohexane. Here all bond angle are 109, bond angle is maintained. There is no eclipse conformer in Newman projection. All the bonds are in staggered manner. So both the strain, the first one is angle strain, second one is the torsion strain, both the strain are removed in this shear form. So it won't exist like this, it exists in this shear form. And there is one more conformer for the cyclohexane, which is also known as the boat form, which is not as stable as the shear form in most of the compound. Only in few compound the boat form exists. I will explain you later in what is the boat form and in which compound that boat form exists. Okay, so I think these two, angle strain and torsion strain, is clear. Why cyclohexane exists in shear form, this is also clear. Now another thing, you need to convince yourself that this is the shear form. When I used to be student, I usually get confused, how does it look like the shear? But you see these diagram, you can easily visualize the shear form of this cyclohexane. From this diagram it becomes very clear that this cyclohexane form is known as should be called as a shear form. Okay,